I am on page 177 down at the bottom under Think About Math. And I've copied this problem and moved it over to a piece of paper, so let's take a look at it here. Elias purchased rectangular and square patio blocks to build a patio. So as soon as they start talking about shapes, I'm going to draw those shapes. And boy, am I on a roll on this one. Everything's crooked here, but it's okay. Here is the square. So he bought blocks with both of these shapes. He paid $2 for each square block and $3 for each rectangular block. The total cost was $3.50. And he bought 150 blocks in all. How many square blocks and how many rectangular blocks did Elias purchase? So they've given us lots of information. They've given us shapes. They've given us money. So we have to figure out how to relate all of this stuff together into one situation. That's where a system of equations comes in. So I'm going to let these be the R's and these be the S's, rectangular and square. So would you agree with me that the rectangular blocks plus the square blocks equal the total blocks? He didn't buy circles or triangles. He only bought rectangles and squares. So this 150 has to be made up of R plus S. The rectangles plus the squares equal 150 total blocks. So there is one part of my problem. That's one of my system equations. I could also argue that the rectangular blocks plus the square blocks equal the total cost, because he didn't buy any triangles or circles or parallelograms. He just bought these two shapes. So the rectangles plus the squares equal 350. But then there's another element involved in this problem that we haven't accounted for. It's the money. The rectangles are $3 each. So every time he buys an R, he pays $3. The squares are $2 each. So every time he buys a square, it costs him $2. Now, if they were both the same shape, I could just combine these two and solve. But they're not. We can't mix rectangles and squares. We have to account for them separately. So here's your system of equations. You've got the first equation is R plus S is 150. And then the second one is 3 times R plus 2 times S is 350. And we need to solve this to make the solution. Okay? I'm going to show it to you both ways. I'm going to show you substitution, and then we'll do it with elimination. Because you need to decide what your preferred method is. I like substitution because that's the way I was taught. But it doesn't matter. We'll get the same solution both times. Now remember what a solution looks like. In this case, it's going to be R and S, not X and Y. But that doesn't change anything. They're just letters, so they don't mean anything in terms of the solution. So starting with substitution, I'm going to solve this simpler one first. And you have to decide if you want to work with the R's or the S's. I'm just going to go ahead and move the R because it's here in front, and I'll put it over here. I'll cancel it here, so we're left with S equals 150 minus R. Then I bring the second equation over here. And instead of S, I'm going to use the value I just found. So 3R plus 2S is 350. Now watch what I'm going to do with the laser pointer first. I'm going to bring this solution right into those parentheses. You do need parentheses because that is multiplying. So 150 minus R, and then we're ready to solve this one. Now I need to distribute first. So I'm left with 3R plus 2 times 150 is 300 plus, that's going to be a minus because 2 minus R, that would be a negative 2R, is 350. I'm going to go ahead and move the 300, eliminate it here. So I'm left with 3R minus 2R is 50. So I'm left with 1R is 50. And you could let that ghost one float away, or you can divide it through. It doesn't matter. So R in my solution is 50. All right. So let me bring that back over here to my solution. R is 50. Now to get S, we need to substitute. I'm just going to back off right here and do it. S is 150 minus, what did we just say R is going to be? 50. So S is equal to 100. And that is the S value for my solution. So here's R, here's S, and here's my solution. The question was, how many square blocks and how many rectangular blocks did Elias purchase? Remember, this is R and this is S, so he purchased 50 rectangulars, and he purchased 100 squares according to the substitution method. So let's try it again with the elimination method. I'm just going to copy this so I don't have to write all that again. And we're going to bring that down here. This is not the substitution method. This is the elimination method. And the only thing that has changed for the moment is what goes in here. Now, it should come out to be the same. If it doesn't, I'll have to start this video again. But we need to know the R's and the S's for the solution. And we're going to use a different method this time. Going to use the elimination method. So, let me write that down. You could also call this the cancellation method. Either term would be appropriate. It's formally called the elimination method. So I have r plus s is 150. And then I have 3r plus 2s is 350. Now, I'm going to focus right here. You could do either one, but I like this one. If I could get a negative 3r right here, I could cancel the r terms. So how do I do that? I can do it mathematically for sure. I need to multiply both sides by negative 3. So here comes this one. I get negative 3r, negative 3s equals negative 450. Same equation, it's just written in different terms. Then I'll bring this one over. I can cancel or eliminate the r terms. So I'm left with negative 1s equals negative 100. And then s would be positive 100. And so I am left with my s term in the coordinate. So here's the s term. The squares are, what did I say, 100? Okay. Now let's figure the r's. So pick one of your equations. I like this one because it's close by. Substitute the 100 in for s. So 2 times 100. So we have 3r plus 200 equals 350. Move the 200. You see why we want you to have very good equation skills, because we have to solve these and we don't really have time to get bogged down in the solution. So r is 50. Now the question is that what I got the last time when I worked this out? Is this solution the same as this one? And it is. So I feel pretty good about that problem. Now, obviously, on a test, you don't need to do both solutions. Pick the one you like, substitution or elimination. We could also have graphed it, but then I would have had to find slope and do all of that. Actually, should I go ahead and let me go ahead? You guys are going to love me, aren't you? I need to make this smaller so I can pull a graph in here. Let's go ahead and see if we can make room for a graph. So my first equation, RS, let's go ahead and get the slope. R plus S is 150. So to get the slope, we've already done it once. We moved the R. So you're left with S equals negative R plus 150. That is slope-intercept form. So the slope for this problem is negative 1. Okay. You know what? I'm not going to do this because we'll have to get a table of values and all this stuff. Let's just not do this. I am glad I showed you how to find slope. That's a good review. But I'm not going to graph it. It'll take me all day to get the table of values and then all that stuff. So let's just let that be. Know that the slope is negative 1 and we'll be done there. All right, there's one more problem on page 177, and I will need to start a new video. So I will see you very soon.